So this is the question that was asked in university examinations. So what is the question? Determine the breakaway points of the system which have open loop transfer function g of s into h of s is equal to k by s plus 4 by s square plus 2s plus 4. So for this open loop transfer function, you are asked to find out the breakaway points. So to find out breakaway points, first what you need to do is you need to identify open loop poles and open loop zeros. Here, open loop zeros are the roots of numerator polynomial. So the numerator polynomial is s plus 4. If we equate this to 0, this will become an equation. So order of this equation, degree of this equation is 1. Because highest power of s in s power 4 is s power 1. Okay. So this equation will have only 1 0. That 0 is also located at s is equal to minus 4. So the number of open loop zeros, here I am taking it as n is equal to 1. Similarly, you need to find out open loop poles. So open loop poles are the roots of denominator polynomial. So here the degree of the denominator polynomial or order of the denominator polynomial is 2. So that this s will have 2 values. So the roots of this equation are 2. The roots of the denominator polynomial are known as the open loop poles. I am representing this with m. So m is equal to 2. So where these are located, that you can find out by using the relation s square plus 2s plus 4 is equal to 0. This is what the equation, right? So you compare this with ax square plus bx plus c is equal to 0. This is the general form of a second degree polynomial, where a is equal to 1, b is equal to 2, c is equal to 4. So you can find out the value of s1 and s2 using the relation minus b plus or minus square root of b square minus 4ac by 2a. You substitute b is equal to 2 and a is equal to 1, c is equal to 4 in this equation. By doing so, you will get the values of s as minus 1 plus j 1.732 and minus 1, this is minus 1 minus j 1.732, and the open loop 0 is located at s is equal to minus 4. So this is the s plane and this is the imaginary axis. Here if you observe, this is the imaginary axis. So this is the point j 0.5, j 0. j1, j 1.5, j 2, and this is the real axis. This point is 0 and here is minus 1 and this is minus 4. So this is minus 1 minus j 1.732 and this is minus 1 plus j 1.732 and this is s is equal to minus 4. So we identified open loop poles and open loop zeros. Now we need to find out the breakaway points. So to find out the breakaway points, you need to write the characteristic equation. the characteristic equation of the system is 1 plus g of s into h of s is equal to 0. You substitute the value of g of s. This value is given as k into s plus 4 divided by s square plus 2s plus 4 is equal to 0. You take the LCM, s square plus 2s plus 4 into k into s plus 4 divided by s square plus 2s plus 4, which is equal to 0. So the denominator should never be equals to 0. The numerator value must be equal to 0. So the characteristic equation is s square plus 2s plus 4 plus k into s plus 4 is equal to 0. Solve this equation, the characteristic equation, and find out the value of k. From this, we can write it as k into s plus 4 is equal to minus of s square plus 2s plus 4, or k is equal to minus of s square plus 2s plus 4 by s plus 4. This is the value of k. Now, to find out the breakaway points, what you need to do is we need to differentiate this k with respect to s. So you find out the value dk by ds and equate this dk by ds value to 0. So here I am differentiating this k with respect to s. It is in the form of u by v. So is equal to b into du minus u into dv by v square. So this is v and this is u and this is du and dv is equal to 1. So you multiply the factors and simplify, you will get the value of dk by ds is equal to s square plus 8s plus 4 by s plus 4 whole square. Now you make this dk by ds is equal to 0 and solve for s. This value is equal to minus s square plus 8s plus 4 by s plus 4 whole square is equal to 0, which is equal to s square plus 8s plus 4 must be equal to 0 to satisfy the above condition. Now, if you observe this equation, the degree of the equation is 2, right? So, we compare this with the standard equation. A is equal to 1, B is equal to 8, and C is equal to 4. Now, you solve for S minus B plus or minus B square minus 4AC. By simplifying these expressions, we will get the value of S1 as minus 1.07 by 2, that is equal to minus 0.535, and the value of S2 is minus 7.465. So these are the two breakaway points of the system. So the breakaway points of the system are S1 is equal to minus 0.535 and S2 is equal to minus 7.465. This is how you can determine the breakaway points of the system.